What I'd like to do is introduce you to a simple problem. I want to draw a rectangle by clicking twice on my board, on my screen. I want to draw the outline of a rectangle. Then, in a loop, I want to click different places inside or outside this rectangle, and I want it to tell me, want it to output inside if I click inside, or outside if I click outside. And I want to do that in a loop so I can demonstrate clicking on this screen. So the first thing we need to do is draw a rectangle between 2 points, and we'll use a window click to dynamically create our rectangle. So as always, the entry point of all of our applications will be a def main. But we want to be able to draw a rectangle, and the logic of drawing a rectangle is requires a window upon which you draw it, a first point, which is the top left point, and a second point, which is the bottom right. So if we call it not point 1, but call it TL for top left, and we call that point bottom right for bottom right. You can add other values like color, but we're not going to introduce color into here. So in order to draw it, we create the rectangle first inside here, and the rectangle is built from the top left point to the bottom right point. And then what we'll simply do is just draw that onto the window you give me. Now that draw rectangle code is useful whenever you need it. You can expand the parameters here, it's up to you. Let's test it out. First of all, in our main, we want to create a graphic window. And to make this interesting, what we're going to do is just make this a little bit larger. So we are rectangle click. Okay, we'll call this, and we'll make it 500 by 500. So there's a 500 by 500 window. Let's just test that works. Quickly run it and have a quick check that there's no obvious error. Bring it over here. Click once, click twice. Oh, well, actually I haven't got any click set up at all, but it's drawn my window. Okay, so I'm happy with that. So let's now draw a rectangle onto that space. Okay, so we call our draw rectangle function, this one up here, and we pass it the window, which is this window here, and we want to pass it 2 points. So let's say your first click point, and what I'll do, just so I can emphasize how I'm doing this, first click point, the point built from the first click is me clicking on the screen. And let's just get rid of anything else, and let's say second click point is a second click on my screen. Okay, so those 2 points are grabbed from clicking that screen. So I pass them in as my top left hand corner, and the second click point I will pass into here. So the theory is, let's make it a little bit wider because it's overspilling. Okay, so that should draw me a rectangle. Let's have a quick test. Run main, get my window over here, click first click, right? So that's my first click point, and down here, second click point. And there you go, I've drawn a rectangle. Now, what I want to do is create a loop that wherever I now click, it will output here, whether it's inside or outside that screen. So how do I do it? Let's have a look at the mathematical logic of it. In order to be inside, it has to be greater than the x and the y value of the first point, the top left, and it has to be less than the second point, so it occupies this space in here. So let's draw that if statement, and I'm going to do something slightly different. What I'm going to do is I'm going to create a we're going to call it location check. You're going to pass it, in order for the location check to work, you're going to pass it 3 points. The first click point, or the top left, okay, you're going to pass it the bottom right point, and you're going to pass it a point, which we're going to check if it's inside in the way that we've said, right? So this one up here, which I've called, is the top left, TL, and that's the bottom right. Okay, so there's my point. Is it inside, or if I click here, it should say outside? What's going to be my location check? Well, the logic is quite straightforward. It would look like this. If the point that I'm checking, right, if I get the X value and the X value is greater than the point top left, and I get its X value, if that's greater, right, so it's, just to be clear, that means that that distance to this edge here, this X distance is greater than this X distance, right? That's what that does. And now I've got a number of ands to do. The point of the Y value bracket is greater than, and we might want to make it greater than or equal to, depending on your logic, right? Whether you want to touch the line, etc. Now that's going to be a really long line of code, and what you might feel is that, you know, that, can I find a shorter way of writing that, a neater way of writing it? So now this isn't a standard practice, but what I want to try to encourage you to do is always look to making small functions that simplify and make the concept much clearer and easier to follow. Let's create a method, call it X. You pass it a point, and what it does is it returns the value of that point, get X. Let's do the same thing for a Y. Call it Y, lowercase y. You pass it a point, doesn't matter what the point is, and then all this does is it takes that point and it returns the get Y. Okay, so they kind of look like really small microscopic functions. But let's get rid of that line and see if we can simplify it. We want to say that the X value of the point is greater than the X value of the point top left. Okay, already the code looks a little bit simpler, and the Y value of the point is greater than, and we can say greater than or equal to, just to think about where we're clicking, right, is greater than the Y value of what? The top left hand corner. Now what you've noticed by this little trick of creating these tiny little functions to wrap these types of lines up is that that line is conceptually simpler to see. Then we want to keep on adding because we need to make sure that the if statement is longer. Now the issue here is that I'm going to go over the line. So what I can do is I can use that slash, and that will allow me to go onto a second line, and it's still part of the same if statement. So I've said, is the X of the point, for the point I'm clicking, greater than the top left? Is the Y value greater? And the next check is if the X of the point is now less than the X value of the bottom right point. And notice just how straightforward it is to work this thing through. And the Y value of my point is less than the Y value of my point on the bottom right hand. Then if all, oops, we've kind of misplaced that. Then if all of that is true, then I'm inside my code. Now that's still a very long line of code, but if you look at Matthew's lecture notes, what you'll find is that it's a lot simpler, and conceptually it's easier to read this. You don't have get Y, get X, all that kind of stuff. Always look for opportunities to make your code more legible and readable. So I'm going to print that's now inside the rectangle, and we're going to test this. If those conditions aren't true, then I'm going to print outside. Okay, so that's a very, very simple location check method. Let's go and use that. So we've come down here. but we want to use that inside a loop because we want to keep on clicking new points. So let's set up a loop down here after we've drawn our rectangle. And the loop is going to just be an infinite loop, so it's just a true inside there. And in there, I want to click for a point, get mouse. I want to run my location check and I want to send it each of these values. So I want to pass it my first click mouse, which was my top right. First click mouse is perhaps not the most useful name, but that's the top left, that's my bottom right, and the third one is my point, the new one that I've added. So let's just shift over so you can see that so it fits all in. So the idea is, let's just make some more space and bring this up a bit. So this will carry on looping, it'll click inside, then it would check the location, and depending on these conditions it'll say it's inside or outside. Let's test it. What's the point of this? The point of this is that you can have complex combinations. You see there's an and in here? So all of the conditions have to be true in order for it to say it's inside. So let's test it out. So first of all, let's create our rectangle. There's our rectangle. Oh, I've got a true and I haven't capitalized it on line 39. So let's go down to 39. There we go. Typical. I keep on forgetting. Right, let's just rerun that and have a look at how this code works. Come back over here, click there, click there. Right, so there's my rectangle. Let's click there. Yes, that's inside, outside, outside, inside. Let's click in different places. Yes, it seems to be clicking everywhere inside. So I seem to be able to click inside. Let's go outside. Yep, inside, outside. You can see as I click, let's click along the edge, go really close up, and come inside, and now we're inside. So actually, that piece of code, the reason that it's crashed is because I didn't close the window, and it's an infinite loop, has problems. So there are several points to this video before I finish. The first is you can create these types of simple functions to make this complex if statement a little bit more readable. Because if I read it, it says if the x for point, if the x value for the point is greater than the x value for the point, the top left, and the y point is greater than, it's easier to read than to use the word getX inside this statement here. So that's one strategy I would encourage you to do. The location check prints this, but it could return true or false based on those, and then inside the code here I could print it based on what I get back here. And that's an alternative way of doing it. So what you see is that I'm creating pieces of code which I can reuse for a number of different purposes. Ideally, I would want to probably look at true and false and returning from here, and then based on getting the value back, I'd want to do stuff with it. That's a rather awful name. So as a strategy for naming, that's too long and not necessarily that useful. Point TL might be better, point top left, point right, bottom right. So you can see several things included here. At the heart of it is this complex if statement where you combine several different truths and different components and subconditions. That has to be true, and that has to be true, and that has to be true, and that has to be true. If you switch them for or, a different type of response would occur.